Alright, so today we're going to discuss our last section in Chapter 7. This is parts of similar triangles. So, if we have two triangles that are similar, in this case triangle QRS is similar to triangle KLM, and I were to draw angle bisectors from a corresponding position, so they're corresponding angle bisectors, then the angle bisector itself, that line, is proportional to any of the sides of this triangle. So, for example, they use LP, this piece right here, proportional to RT, the two angle bisectors, equals LM over RS. I also could have said KL over RQ or KM over QS. All of that would be perfectly valid possibilities. I can't use the individual KP and QT, but I can use the entire length of sides. So, for example, I have a two angle bisectors, and we're going to assume, again, the directions for the homework will say the two triangles are similar. Use the proportionality statements to solve for the missing variable. Well, if they are similar, our angle bisectors, 24 over 15, must be proportional to the outside sides, 30 over x. So I could leave this x as just x. I could make it like 7x minus 5. I can do whatever I want to, but this is still the general concept, how we're going to solve this. Now, as always, we should reduce 24 and 15, have a 3 in common, so 8 over 5. So when I cross multiply, I get 8x equals 150. I need to divide both sides by 8. When I do that, we are going to get x equals 18.75. So that's our answer for x. And that's how you're going to use the angle bisector proportionality theorem itself. You're just going to have two triangles that have angle bisectors. They have to give you the angle bisector lines themselves. Maybe I make x one of those, or maybe I give you both values, and then give you some outside values as well to set up. Similar concept if I were to draw the two medians of two similar triangles. So again, we have similar triangles. I'm drawing the corresponding medians. So they're going from the same spot. C and Y are both in the same areas, and they're going to set up again their own proportionality statements. So in this case, similar way. So CD over YZ, our two medians, is proportional to the entire line that they just split, AB, and this entire line, WX. Now, this should technically actually have a double tick mark right here, because while these two are equal to each other, they're not equal to that original diagram. So, similar concept. We have these two triangles. So we have our two medians. Again, the directions tell us they are similar triangles. So the ratio of the medians must be equal to the ratio of the sides that they split. So if each piece is 15, the whole line is 30. If each piece is 8, the whole line is 16. So we should reduce this as far as possible. They're both divisible by 2, and that's it, so it's just 15 over 8. So when I cross multiply, we get 8x equal to 180. I divide by 8, and we get x to equal 22.5. And again, I can make this x more complex. I can have you find the sides over there. I can only give you one of those values of the whole line, that kind of stuff. It doesn't really matter. This is the same general concept. These are very simple equations really to work with. There's not really a whole lot of trickery that can go on in these kind of problems. They generally have to give you pretty much all the information you truly do need. Last one is a triangle angle bisector. So we have a single triangle. It's not similar to anything. But the thing is, though, by drawing the angle bisector to that single triangle, I'm going to set proportions for the lengths of all the sides. Here's my angle bisector JM. Notice JK and KM are the sides on essentially to the left or above the angle bisector. They're going to be the same, I guess, setup. And then JL and ML are the two sides to the right or below the angle bisector. So if you notice the ratio, KM over LM, the two angles sides split by the angle bisector, is equal to the ratio of the two sides of the angle, KJ over LJ, in the same areas. So for this one, what we're going to do is we have our angle bisector. So the 16 and the 9 are together, 2x plus 5 and 4x minus 1 are together. So here's how we set it up. The two sides that are split, 4x minus 1 over 9, equals the sides that form it, 2x plus 5 over 16. Now there's nothing to reduce in this particular problem, so we just need to straight up multiply. 16 times 4 is 64x. 16 times 1 is negative 16. 9 times 2 is 18x. 9 times 5 is 45. So I need to subtract the 18x to both sides to move it over. We get 46x minus 16 equals 45. I then now need to add the 16 to both sides to get 46x equal to 61. And then solve for x, we need to divide both sides by 46. So the rounded decimal would be x equals 1.326. And that's all we really had to worry about in this last section, right? They're very straightforward formulas. Really, which I guess would make this chapter slightly difficult is the fact that there's a lot of formulas to remember. But they're all very straightforward. We have our angle bisector for two similar triangles, angle bisectors with the sides match. The medians, again, the medians match with the sides. And for this last one, we are to the bottom or to the right of the angle bisector. They're together up top. These are together on the bottom over here. Okay, so that's it for chapter 7. So again, if you still have any questions on any of these material, please make sure you come and talk to me in class. And then we'll see how we do. You have a quiz coming up soon. You have your test to prepare for as well. So good luck.